So today we're going to be looking at two demos. The first one is called the stoplight reaction and the blue bottle reaction. And I've already pre-prepared everything because there's a waiting period here. There's 250 milliliters of water in each one, and then I've added some highly concentrated sodium hydroxide to make this both solutions basic. And there's dextrose, which is it has glucose in it. It's a sugar basically, and we have two different indicators. The one for blue bottle is called methylene blue, this one right here, and then the one for the stoplight reaction is called indigo carmine. What we're seeing here is a reversible reaction called the redox reaction, and the details of a redox reaction is something we're going to encounter after this unit, or after acid base unit. So we'll get to the chemistry of that. Today our focus is on the rate of reaction, the kinetics, how fast the reaction is happening. So what I'm going to show you, I'm going to shake both of these, and by doing so I'm adding oxygen as one of our reactants in the solution. And by having the solution with oxygen mixing together, we're inducing the forward reaction of that redox reaction. So I'll start first with indigo carmine. We'll see kind of how well the color change occurs, but that's what we're looking for. So I'm going to shake it, adding oxygen to it. And let's see if I was able to induce a bit of a color change. Perhaps maybe it needs a little bit more. All right, I'll set it down, see if we can kind of see a variety of colors there. Ideally, it would have changed to something darker orange, almost red. But the blue bottle for sure should work. Even just like bumping into it, it induces that reaction pretty quickly. So here's our blue bottle. It's clear. By shaking it, changes to our blue bottle right here. So now what we saw is the forward reaction. How fast the reverse reaction is happening depends on many factors. And one thing we could do is we could test it out by either submerging it in cold water. So if you think about it, if I submerge it in cold water, how would the rate of reaction be affected by that? Or if I submerge it in hot water, how would the rate of reaction will be affected by it? So it looks like our stoplight reaction might not have worked, but our blue bottle reaction is working. In order for me to kind of speed this up, one thing we can try is put this in our hot water. And let's see how much time, if we were conducting a lab, we would have started the timer as soon as we were shaking it, as soon as we induced that forward reaction. So keep in mind that in kinetics, the rate of reaction is dependent on many factors, but one for sure would be the concentration of this solution that you're using. So that will be something that will be affecting. So it's starting to get lighter, but ideally we know that if we're able to induce this back, it should go back to the clear solution. So we'll give it some time